Tech Trends podcast, where we discuss the latest manufacturing technology research and news. Today's episode is sponsored by Modern Machine Shop, Made in the USA podcast. More on them later. I am the Director of Technology, Benjamin Moses, and I'm here with
Stephen Lamarca, AMT's Technology Analyst.
Steve. Welcome to a casual Friday.
Yes, we're recording on a Friday. This is so fun.
Yeah.
This is actually okay. I did not understand the gravitas and the significance of this recording session until you mentioned that, because you're always on camera in a suit.
For those of you watching,
this is like the first time AMT has put you on camera for anything, and you haven't been in a suit.
The way I normally look on the weekend.
This is a rare edition. This is episode 90.
90, that's right.
Big deal.
They better get the screenshots.
I hope I got that right.
The audience better get the screenshots while they can, because you'll never see me in this again.
Never again.
Steve, I want to talk about how we select our brands for tools, like hand tools.
All right, buckle up. Growing up, my dad always had Craftsman tools.
Sure.
And I know you're a big fan of Craftsman tools.
Yeah.
Then I got into the video games. PlayStation 2 rolls around. I remember playing a car game, a racing game called Auto Modelista.
Okay.
It was really cool because it was a cel-shaded game, meaning, it was the cars were accurate in terms of their dimensions and shapes, but the graphics was cel-shaded to make it look like anime.
Yeah.
Make it look like
more 2D
it's
style.
cartoons.
Yes. I like that style.
But really cool. But one of the coolest things, one of the fun things that wasn't really, it was part of the game, but like wasn't imperative to the gameplay, was you could customize and set up and organize and decorate the garage.
Oh, cool.
That where you store your car.
Okay.
And part of that was the stuff you could hang on the wall.
Yep.
And of course there's the decals that you can put on your car to make it look like Because race car and whatnot. But that game introduced me to the brand Snap-on.
Okay, cool.
And years go by, I become an adult, and it's about time that I start buying tools to actually work on stuff, whether it's the car or just IKEA furniture. It's time to get a good time to start building a set of tools. And my mom and dad passed down. Well, my mom passed down a set of my dad's socket set to me. Don't know where it is.
Oh, no.
Don't tell anybody. But, it's a really nice socket set. And,
Sure.
my mom was originally trying to give it to her sister's husband, John, my uncle John, who ultimately he's an electrical engineer, and he's like, oh no, this is a nice socket set. Okay. This needs to stay in the family. This needs to go to Steve. And so that's really, and of course I lost it. It's somewhere I know though.
Misplaced.
Anyway, it's just misplaced. Anyway, when I look into buying myself my first set of tools, I'm just looking for a toolkit, which I didn't realize for actual handy people who know their way around hand tools.
Sure.
Nobody buys a toolkit. Nobody buys
sure.
a tool set.
Okay.
As a starter. You buy a big, sheet metal toolbox that you wheel around, and then you fill it with each tool as you need it. And if you want to get fancy, you get custom laser cut foam inserts to each drawer, or you just throw them in there and let them clank around.
Yeah.
But I'm not about that. Just let me get a good starter set.
Correct.
But anyway, when I was shopping for this original tool set, I was it went back to my days in middle school and playing PlayStation 2 and Auto Modelista. I was like, let me, I have an adult wage. Let me buy some nice tools.
Sure.
The saying is, you buy nice tools, you only buy them once. Buy once, cry once. That whole thing. So I want Snap-on tools. Aren't they the best?
They're known. They have a reputation.
So anyway, I look into trying to buy Snap-on tools. Go to Google.
Right.
Snap-on.
Yep.
Nowhere can
Can
you buy Snap-on tools online.
Goodness.
I hit Reddit, which I hate doing, but I go to Reddit, and they're Snap-on has built amongst civilians, amongst people like me, who just want, the clout of having nice tools.
Sure.
People like me who want to buy Snap-on their marketing team has done this incredible job, and this also goes for Mac Tools and Matco.
Okay.
These they have developed this clout that these are for professionals. We don't want the Sunday, the Fairweather, the Shadetree mechanic.
Right.
to have their grubby little soft hands on these tools. These are for real technicians.
We'll get into soft hands later.
Yes, we will. You know, and like so their whole thing is like this allure to the civilians, to people who are not in that profession, are like, wow, they only sell to mechanics.
Yep.
These must be the best tools because they want to keep them out of, you know, civilian hands.
Yeah.
Just like HK doesn't sell the MP7 to civilians.
Sure.
Like, that's not fair. We need the MP7.
There's parallels across different industries.
Anyway, yeah, and it's like it's the HK of tools. Who doesn't want this until you handle an HK and you realize they're junk? Foreshadowing. So then, so years go by. Then getting friendly with my mechanic now, Carter.
Sure.
And he tells me everything that's like
all
about, you know, the big American tool companies that are actually like half of their tools are actually made in China. They're all overpriced like they're made in the USA, but like very seldom are actually American made tools.
They're taking a global strategy.
Yeah.
Parts,
But like their the way their sales campaign is, I don't want to say toxic or hostile, but it's aggressive.
Yep.
And so not only do they have this allure, this exclusivity to civilians. I keep saying civilians, but it's a lack of a better term. Non-mechanics, non-professionals that like, oh man, they only sell to professionals, so they must be the best.
Right.
But they sell out of these trucks. So you see the Snap-on truck or the Mack truck or the Matco truck, and they drive the salespeople also drive the truck, and they sit and wait for outside of like car repair shops for a mechanic that needs a tool desperately, and they want to get a job done because, you know, you don't want to charge the customers for all of the hours to do something simple. But if you need a tool, you need a tool. You want the right tool to do the job. So a mechanic will go out in like a panic to the Snap-on guy, or if they, you know, just get paid, which I'm sure the Snap-on and all of the tool trucks are smart, and they know when the mechanics that they sell to get paid, and they're like, oh, they just got their paycheck. It's time to sell some tools they don't need, and it's just really aggressive and predatory.
Right, data distribution model.
Yeah, but on the plus side, the tool salespeople come to you.
Sure.
Like you don't need to go to a hardware store and get it like that day. They come to you. Like if you need the tool, they come to you. And I guess that's where a lot of like the profit goes.
Sure.
You would think. I doubt it. But you know, you'd like to think that way. But it's just like these mechanics who already barely make anything pay an astronomical price to not get them. So naturally, when I find all this out, and fast forward a little bit more, I'm working in the manufacturing industry now. We get the Pocket NC.
Yep.
It ships with a Wera hex driver and several not Allen keys, because the Wera tools are German, and the Germans call them L keys for whatever reason. Whatever, win a world war, and they're really nice. But I end up like, you know, I step away with driver in hand. Away from the test bed, away from the Pocket NC, and I go to somebody's desk, and like a dingus, I set the driver down, never see it again. Don't know where it went, it's gone forever. So I reach out to Pocket NC, he's like, hey, where do I get one of these drivers? And Pocket NC like tells me politely, they don't actually like mean this in a hostile way whatsoever. I love Pocket NC, or Penta Machine. I'm like, hey, can you guys send me another one of these drivers?
Sure.
I lost mine. And they're like, dude, that's a German driver. It's like a $30 driver, dude. So
go pound sand.
Sorry, like you just go to your hardware store and get 3mm hex key. And so I end up reaching out to the group of fine people on the Prepared websites, the Prepared Slack team. I reach out, hey, where can I get like a replacement Wera wrench? And they tell me about KC Tool. And KC Tool is this great website that sells all German tools, all the German tool brands, and they've been great, and they amazing prices on these high quality tools. Like I've given them way too much money. But you know, they've delivered, and Now, you do end up waiting like a week plus for your German tools to come in.
Sure.
Because if they don't have them on hand, they're coming overseas.
But you're able to go online, say add to cart.
But, I'm not a professional, so, I got time.
Yeah.
But it's cool. And
yeah.
it's nice knowing that I have the German tools. But
Right. And that's more industry, so that caliber of
yes,
quality of tool.
whenever we go to a job shop, to a factory, to a plant, doesn't matter how small the manufacturer is or how big they are, they all have Wera tools. When I went to Sandvik, I thought, this is how dumb I am. I thought Sandvik had custom-made Wera tools for them because the Wera wrench or the Wera drivers, the handle was the same colors as Sandvik's colors, yellow and red. That's cool. And then you dummy, that's for like electrical insulation. Wera tools, these German tools are apparently like comparing Snap-on to Wera isn't quite fair because Snap-ons and Matco and Mac, they're for automotive technicians. And Wera sells to machinists and electricians or electrical engineers.
Right.
So electricians are just probably buying Husky and Cobalt.
And that's a funny point because we talk about the reputation of tools and where things have progressed recently. And, for me, like Craftsman was like a top tier. And then to your point, I've always had like a old travel tool set. Yeah. I didn't buy individual tools for those things. Like if I buy a circular saw, I'll buy a single circular saw. Then if I need a jigsaw, I'm not going to buy a kit of those.
My mom still has my dad's Craftsman power drill.
Yeah.
That he bought when he was in his 20s.
Yep.
And now and it still works great.
Yep.
It's a little sketchy because when you pull the trigger to start drill, you see sparks come out like the little vent on the side, and it smells funny when you get going really hard. And the power plug doesn't have a ground; it's only a 2-prong. Things have changed, but it's made of metal.
Yep.
It was made in the USA. Craftsman, sadly, they have a made in USA line if you want to go that far, but
and the consumption of these hand tools is very different than the models in the past. So being able to add to cart now or go down to the store, like we mentioned when we were prepping that, we'll see Wera tools, but at the same time, you'll also see Cobalt and Husky from like Lowe's and Home Depot because those are accessible. And also, in some cases, you want a kind of disposable tool.
Yes.
So it depends on the scenario. And, I bought a set of Craftsman. I was like, man, this is going to be a great deal. And I realized this is not the Craftsman of 20 years ago. I had things breaking left and right, and the wrenches are okay, but the change in quality or change in perceived quality and how they're used has changed over time a lot for a hand tool.
Right.
So.
And there's also like a brand of, I was watching a YouTube video of a truck technician, like an 18-wheeler technician, was saying there's a time when you go for Snap-on or Mac or Matco. There's a time when you buy the nice tools like that. And there's a time when you just go to Harbor Freight.
Yes.
And he showed, the guy in the video showed two crescent wrenches. These were massive crescent wrenches. Like the crescent, like the nut that this thing was supposed to turn is probably like 4 inches.
Right.
Like it's nuts how big this thing was. And it's like, this is a Snap-on one. And if you notice, the end of the crescent wrench where you would grip with both hands has a big, it's almost like an anvil.
Right.
It's for, you put it on the nut and then you hit it with a sledgehammer.
Yeah.
I forget the name of this wrench.
Sure.
But it's like, this is a $250 crescent wrench that you will use once every 5 years.
Yeah.
Go to Harbor Freight, get it for $30, saw it in half. Now you have 2 of them for $15. And you hit it with a hammer.
Yeah.
You hit it with a sledgehammer.
That's fair.
Why spend that much for something that you're only going to use once every 5 years, and it may as well be disposable because your job will change so many times that you'll end up having to lug that thing around.
Yeah.
So there is a time. The moral of the story is there's a time when to go fancy for tools, and there's a time when not to.
Let's talk about your soft hands.
My soft hands, the ones that do not, my hands do not deserve German tools. So our industry colleague Russ, he's a good friend of ours, and I hang out with him as often as I can. And every Tuesday night he hosts like a jam session at his house.
Yep.
He works from home. He's fully remote now, and they have a room in their basement that they've turned into a their home office and studio.
That's cool.
And they're just like he has it as a production studio for like both doing his webinars and for actually making music. It's really cool. But I mostly go there every other Tuesday just to listen to people play music,
right?
Because it's really fun, and it's awesome watching people work. There's something about like appreciating an artist's art,
sure,
and actually watching them work.
Yeah.
Like one of them isn't enough. You have to see both. And it's one of the reasons why I go. But anyway, this past Tuesday, I go over and Russ hands me my bass guitar, which I bought back in when I graduated high school.
Right.
I bought a pretty nice bass guitar, thinking that I would learn how to play. And I guess I learned how to play a little bit, but I am not good musically. I like to sing,
sure,
and I'm okay at singing, but like when it comes to instruments, nope, not me. Don't deserve the German tools, man. Anyway, he like coached me and was like, "You're gonna play space." I think I played for 15, maybe 30 minutes,
sure, and
already had blisters on my fingers, on like my middle fingertip. It was this big, gross blister.
Yeah.
I was like, "Hey, Russ, I gotta stop playing."
That's
like,
enough.
I'm only playing like one note over and over again.
Right.
But I have to stop now because for whatever reason, it's dark in his studio. My finger really hurts, and I can feel like this bulbous thing on the end of the fingertip. Huge blister when I got home.
It's your body telling you to stop.
Yeah.
That's funny. Yeah. And I remember...
Soft hands.
I remember to be honest, every time I do any kind of work, you can't do that when you're playing guitar. I wear gloves.
Yeah. Imagine. I think I'm going to be one of those nerds the next time to play bass with a pick. I don't want to be that guy.
You got to get a pick, man. You got to keep playing.
Yeah, just got to keep playing.
Keep playing.
I'm going to have gross, rough hands.
Tell us about today's sponsor.
Tune in for Modern Machine Shop's Made in the USA podcast to explore manufacturing issues faced by companies making an intentional choice to manufacture in the U.S., Featuring commentary from OEM leaders, Made in the USA blends its nearly century-long expertise with a unique audio storytelling experience to shine a spotlight on the past, present, and future of American manufacturing. Find Made in the USA on Apple Podcasts, Spotify, and all major podcast platforms. Follow Modern Machine Shop on Twitter, Facebook, and LinkedIn.
Thanks, Steve.
Bet.
I got a couple of spicy articles.
Talk to me.
First one on nuclear power.
Oh, heck yeah.
My favorite power.
When are we going to have nuclear power? Maybe this will tell us. Let's go.
So this is from 3D Natives, how 3D printing is used in the nuclear power sector. I'm sure I'm pronouncing this incorrectly, but fine. And it has a bunch of use cases. I'm going to go with the three that I found very interesting. One is, and Alabama, feel free to correct me if I'm wrong, but this bullet is safety critical components in an Alabaman reactor.
Alabaman. You've heard of Florida man. Now we got Alabama.
That's one of our hashtags for today.
Heck yeah.
So one of these is in the Tennessee Valley Authority Browns Ferry nuclear power plant in Athens, Alabama. The second most powerful nuclear power plant in the country. So fairly active.
Oh, we actually have nuclear power plants?
Oh, yeah, definitely.
Awesome. It's good to know.
The TVA is massive. It's connected to the tail of the dragon if you happen to be in that area.
No way.
We'll get in that later. So it's interesting because considering their scale and how much output they have, they worked with Oak Ridge National Labs, which the name will come up a lot in this article.
Ornal.
And they installed 4 3D printed fuel assembly brackets for use in their reactor back in 2021. And it's very interesting because it's super regulated, so the ability for them to both print the part and have the confidence to put that in the assembly. This is one of the most important parts of the section. So
sure, it's
very interesting. And the article gets into a little bit of what they used. So they used laser powder bed fusion and material called Trueform 316. I'm assuming it's stainless steel 316, but and it gives some of the consistency. So that's the first one I want to mention. So that sets the stage of some of the other ones we want to get into. And also it's a good takeaway because taking the concepts from each of these bullet points and how the parallels across all industries on this. So the ability to create brackets and complex geometry like that's the first takeaway here is, we can do very, very complex nozzles, but the ability to create safety fasteners and critical hardware, that's a very good takeaway. The other one I have is Siemens in Slovenia. So this is an international article, not just the U.S.
Sure.
The first 3D printed operational part in the nuclear power plant as part of a work with Siemens is a 108 diameter metal impeller using
108 what?
Millimeter.
Millimeter.
It's a little small guy, not super big. Impeller for a fire pump constantly in operations at the nuclear power plant.
Oh, cool.
So this is, again, back to the criticality of it. And the cool part about this is the reason they use additive manufacturing is because the original plant was commissioned in 1981.
Mm-hmm.
So to go back and get that part from they couldn't. So this is back to supply chain issues
that
they run
That
into.
part is discontinued, and plus a pump impeller is probably a 5-axis CNC machined part, potentially, like a turbocharger.
So
impeller.
in the pictures, you'll see their example. So I think the first one was actually cast. And that's why it's a very good example for additive. Is the first one looks like it was cast, and they did a plastic model mock-up, and then they show you the 3D printed model. So
nice.
I think it's a very interesting use case. And since it's modern and Siemens is involved, they're able to create a digital twin of that through their process. Since they
even still, if it's cast, that mold is probably long gone. It was from 1981. So
it's probably holding up someone's table at this point now. And I think the last one I want to get into is Purdue University received a grant for $800,000 from the DOE to participate in the creation of 3D printed microreactors. So we could have a reactor right behind your desk. So the university would participate in a transformational challenge reactor demonstration program. So they want to see, the efficacy of microreactors and, where they can deploy and stuff. So they would create the first 3D printed microreactor by 2023. And the takeaway here is, that's kind of cool, but the ability to embed artificial intelligence as part of the in-process QAs to improve the reliability and quality of the part. So they want to use artificial intelligence techniques to allow more data-rich and cost-effective nuclear component qualification process.
Nuclear power, micro reactors, artificial intelligence. We just got so close to Terminator. It's not even funny.
2023, yo.
I think that honestly, like, that's one of my favorite parts of Terminator was when he's got to switch reactors because the other one's like old and overheating, so he throws it. Becomes it's a little mini nuke. It's like, we need that. I mean, obviously, we're not going to be using nuclear power if it happens. We saw what happened with Chernobyl, and we don't need little mini Chernobyls all over the place.
So in the end, I mean, the takeaway is, one, I think from my perspective, nuclear power will actually be a long-term solution for power generation.
Absolutely.
And they are looking to get to a cleaner process, because some of these cases talk about cleaner nuclear power. But the 3D printing applications that they talk about here are applicable to a lot of different industries. Like the last one they mentioned about artificial intelligence to help train and help the decision-making process. So you get a part, is good or bad? Should I use it? You'll have enough data and recommendation to say, yeah, maybe, or good. So
imagine we completely stop using coal, we're all using nuclear power, and then the next problem there is, what do we do with all of this depleted uranium? It's like, you could bring down the prices of ammunition.
Speaking of high prices, tell me about Bugatti and metrology.
Bugatti. So this article is really cool, and it goes into this guy Gregory. The name's actually not Gregory, but it's definitely a French version of Gregory. So it's spelled G-R-E with accent aigu, G-O-I-R-E. I'm just gonna call him Greg. Works as a metrologist at Bugatti, and this guy is responsible for basically ensuring that every car and every component of every car meets the strictest tolerances and standards so Bugatti can make the finest product out there. And it's not just for the luxury good clout, but it's also for their performance reasons. Like they're making cars that, I assume, I haven't followed the Bugattis in forever, but I assume at least come close to 300 miles an hour, if not exceed 300 miles an hour these days. And when you're taking a car that fast and it's fighting aerodynamic drag that hard, everything needs to be locked down and exactly to spec because this car is actually wind tunnel tested, and the tires, I think, go bad before you run out of gas at speeds that high. So everything, like naturally, when you do a tire change or like, I think I read somewhere that like the new Bugatti, every 4 sets of tires, you need to replace the wheels. so metrology, and it's because the material gets out of spec that quickly at high speeds and whatever, and because of they can only ensure that the tire was changed properly so many times, and there's so much forgiveness that they can. Even though pretty sure there's only like 10 technicians around the world that are certified to change the tires, and each set of tires is like $50,000. That when you ding up and dent the wheels so much and they become out of spec, and you can't just add wheel weights to them to get them back in balance properly. So naturally, there's a lot of metrology. But I want to tell you all that to tell you this, or to discuss this with you, rather. It's wild to me that luxury goods, exclusive, high-end goods that only the 1% of the 1% can afford, have fully done a 180 since at least seemingly since I've started working in the industry, from being this is a all handmade product,
right?
Because only human eyes and the human touch can make a product as fine and exquisite as this. And finally, a company like Bugatti is like, no, brake rotors and brake calipers need to be 3D printed. We need to 3D print stuff out of Inconel and ceramics and carbon ceramic, and we need the absolute best metrology possible and available at the state of the art level, because human eyes just aren't good enough for it. And frankly, the price can pay for it. So it's really cool how we've gone from like, I think handmade technology or handmade quality, and even we talked about this a couple episodes ago with Sig Sauer. They basically said on record that if your design can only be handmade, it's a bad design. And Bugatti's doubling down with that. It's like, handmade stuff is dead. Long live advanced manufacturing.
And I think it's getting a lot of consumer acceptance of that concept also. So at that tier of car, the idea of handmade fits that consumer. But I think they're pushing the envelope to say, this design is so unique, we can't hand make it, right? If you want a good fit and finish, we're moving past the human and certain levels, right? The human eye, it's actually very hard to compete against that. So if you talk about paint and things like that,
it sounded like I'm throwing shade, but the human eye is actually almost unparalleled until recently.
Between the improvements in traditional subtractive manufacturing to get consistent part quality and the ability to have very unique designs, the need for hand fit and finish is probably, to your point, more of a archaic way to manufacture parts. Now, that being said, I'm sure you'd like a hand fit shotgun.
Oh yeah, hand fit shotgun.
So there are certain things that you still want hand fit,
or hand polished acetate temples on a fine pair of sunglasses. But that's not a critical component to anything.
Yeah, exactly.
I don't need my sunglasses to go 340 miles an hour.
So when you do mention about the tires, at some point let's talk about high cycle and low cycle fatigue.
Okay, I'd love to hear about that.
The article I've got, Steve, is GE to invest over $450 million, not dollars, $450 million in U.S. manufacturing in 2023. So this comes from their site, ge.com. And it goes over a couple of points, and the key takeaway here is where the large companies are reinvesting to stay ahead of the growth curve or the technology curve. The first one is their aerospace group. They have a joint venture for their aero engine operations. They're going to invest $17 million in Ohio to look at maintain and expand capacity across several lines. So that in itself, they want to keep up with growth. So they're growing their manufacturing capability. And also, in Alabama, they're going to have $60 million to
Alabama,
back to Alabama, to increase their additive manufacturing line. So back to growth.
Cool.
To Lafayette, Indiana, they're going to invest $7 million to increase tooling support for their LEAP engine, for maintenance and repair, and improve their capacity and productivity. And in the last place in Kentucky, they're looking to invest $4 million on maintenance improvements productivity, quality, and maintenance improvements across several engine lines for the U.S. military. So I think you're seeing fairly different use cases both on the nuclear article and on what GE is investing in.
Mm-hmm.
When I would say almost keep up, because depending on where they are in their life cycle, if they're investing now, if they're going to truly spend that much for this year, that means they've already had the pipeline of what they want to purchase, and they're executing on that purchase plan. So they're well on their way to meet a growth curve for 23 and beyond. So I thought that was a very good look on all of their stuff is aerospace focused, so aerospace and military. So that's a very interesting look at spending in the Midwest, basically.
Yeah.
So South and Midwest.
That's awesome. It's really good to hear that GE's buckling down on advanced manufacturing.
Yeah, absolutely. Speaking of advanced manufacturing, Steve, tell me about space and 3D printing.
Yeah, so KFC is bringing back the double down. I'm sorry, wrong article.
Wrong podcast.
TCT Magazine, Relativity Space secures an FAA license for the 3D printed Terran 1 rocket launch.
That's cool, man.
That's a big deal.
That's big. Tell me more about this. There's some subtleties we need to talk about.
But like I always do, forget the article.
Yeah.
Let's talk about something else kind of sort of related to it.
Sure.
If you've followed the rockets made by any of these major non-NASA private companies,
yep.
They're all making their rocket fuselages with 3D printing.
The fuselage. The cylinder.
The cylinder. Yeah. We're talking the simplest part. But like everybody's doing it, whether it's SpaceX or Blue Origin. They're big dumb barrels that they're shooting up into the sky. They're 3D printing.
That's fascinating.
And it's like, we have been told for the past, I don't know how many years, that one of the big benefits of additive manufacturing is the complex geometries made possible from the technology. And it's like, this is a cylinder. This is just a circular wall. Like we could use, gantry CNC machines. Sure. We could use a big lathe, probably found in Australia. We can use fiber placement.
Yeah.
Fiber placement's been making the best carbon fiber cylinders for Boeing.
Yeah.
Why not send it into space? Like, you have so much more money than them. And we're 3D printing it. Yeah, we're 3D printing barrels.
I'm sure there's some nuance in it, but the takeaway, it's
like this goes against everything that design for additive manufacturing is saying.
And I think it's fair to look at the scale of it too, because these aren't small barrels.
No, they are big.
They are big, right?
And they have to, because of the materials that you can print with 3D printing, they can sustain going in and out of atmospheres.
Right. So
unlike carbon fiber gets a little hairy.
Yeah.
The other cool thing that we've noticed is, or that has been pointed out to me, a lot of these barrels, these cylinders, being printed, the build plate is vertical, meaning the print is horizontal, because they have to be. They're making big long rockets.
Sure.
And when you're making a big long rocket, if you're 3D printing it to make it out of one piece, you either need a big building that goes high up, or you need an expensive foundation that goes deep down.
Yeah.
And then you have to send all of that material either up the build, or all of your printed part down into like a well.
Right.
They're printing it sideways.
Yeah.
And my speculation is that if they print it vertically, so the rocket is being printed up and down, or, the right way, then as the material is added on, the load that the material at the base of the rocket, assuming the base of the rocket was printed first, of the cylinder was printed first, is going to have to bear more and more weight as the part's being printed.
Right.
And as it settles slowly and cures over time, not cure, but as the material settles, it's going to settle differently from the material at the top, which is going to have like no weight on it. So they're going to settle totally differently. And maybe by printing them horizontally and rotating the build plate, gravity has an equal effect. It has an equal effect across all of the material the whole time that the cylinder is being printed, which is really cool to me because I'm like, we're getting back to classic watchmaking technique. This is they're printing rockets via a tourbillon. And it's wild and crazy expensive.
So you did hit on two things, right? There's the thermal distortion as you're printing, and the load because it's such a big object on the part going to the base of the part. And I do agree with you. Length is an issue. I think the answer is probably simpler than you expect. I think there are issues of just height. I think if they can scale.
It might just be height.
They can scale their factory lengthwise much easier than they can scale height. So if they're trying to build like several different engine lines or fuselage, then they can do that easier.
Right.
But you do when you do.
But how do you support?
That's the issue. So that's been solved a long time ago with.
Excuse me, Ben.
With long turning. So if I'm turning a 10-foot shaft, I have to have a steady rest part way to support it. So as they're printing, they're adding steady rest or some kind of.
What's that called in a lathe?
A steady rest.
I thought there was another term. Is it really called steady rest?
I hope so. Let us know.
Darn it.
In the comments.
Because I thought like the big
Email
thing
Steve.
that Mazak said was essentially what it boils down to. What separates a regular lathe from a Swiss lathe is not all like the live tooling and not one being smaller than the other, but it's that the bar stock of the completed part is actually supported by.
What's the other term? They're supporting the backside of it on hanging outside the machine. So let's back to the
gosh darn
engine.
it, man.
The nice thing about that also is that they're able to print complex structure into the skin. So they're not just printing the skin itself, right? So we are a little bit marginalizing the complexity of it, but it is interesting to take away.
Turn it on a lathe.
That the shift in that scale to a horizontal process, which I agree with you. They're trying to use gravity to their benefit, and for me to see that, and that might be a good interview, is figure out why they're doing it that way for road trip and steel.
I also refuse to believe that there's some sort of internal geometry going on, because if you open this article and you look at some of the pictures, the surface finish looks like
a little rough.
Looks like poop, man. It doesn't look good.
Yeah.
It looks like it came out of a McDonald's soft serve machine.
They need to put down a lot of material.
But you know what? Hey, they're the ones who are getting like $1.3 billion in funding, and not me. So
I like the use case a lot, Steve. A lot of stuff in space that's 3D printed.
Yeah.
Do more of it. Where can they find more info about us?
amtonline.org/resources.
Awesome. Thanks,
like,
Steve.
share, subscribe. Bing bong.
Bye, everyone. Is that your catchphrase now? Bing bong.
That's how we're closing it out.
That's how you're closing it out.